Okay, today we're going to talk about tuples. What is a tuple? Well, it's a sequence of values separated by commas. A tuple may or not be enclosed in parentheses, and most people, when they see them first, think the parentheses are essential, but they're really not. As you can see here, both T1 and T2 are tuples, but T1 is not enclosed in parentheses. But you'll see that when you print T1, Python will actually put the parentheses there, kind of good form. Okay, so stop the video and doodle, create your own simple exercise to demonstrate the contents of this slide, then come back to the video and go on. Okay, you're back. I assume the next thing we want to talk about is extracting things from tuples. And you extract things from tuples by numerical index, that is position, same way as lists or strings. Slicing also works exactly the same way. You can have a tuple that's very long, which slicing might not make sense. So here you can see that I referred to the first element in the tuple T1 and got it out and put it in X, and then I printed X and I got what I expected. And the last element in T1, I got it out with the -1 index, and I printed it out and I got the 3. Okay, stop the video and doodle, create your own simple exercise to demonstrate the contents of this slide, then come back and start the video again. Okay, you're back. I assume you've done your thing. Combining tuples, this is something, it's neat. Okay. Same concatenation and repetition we use with strings works with tuples. So here's T3, and I can print T1 plus T3, concatenate the two tuples, and I get a 6 tuple. And here I get print 2T1 plus T3, and I get a 9 tuple. So stop the video and doodle, create your own simple exercise to demonstrate the contents of this slide, then come back and start the video again. Okay, you're back. I assume you've done your thing. Tuples are immutable. If you try to directly change a tuple, like this says I want to replace the first element of the tuple T1 with 4, and here I printed it out, and you see that the change did not happen. Also, I want you to do this in CoCalc, and you'll see that when you try to do this, the interpreter will scream at you. Okay. Stop the video and doodle, create your own simple exercise to demonstrate the contents of this slide. Okay, you're back. I assume you've done your thing. Tuples are immutable, but here's an interesting thing. A tuple can contain items of any type. Some types are mutable. So the mutable item in a tuple could be changed, and this will be reflected in the tuple. So I've got list 1 and list 2, and TT is a tuple whose elements are lists. Yeah, you can put anything in a tuple. And then I print it out and I get 1, 2, 3, 4, 5, 6. Then I change list 1 by appending an A to it. And then I print out TT, and it's the same tuple pointing to the same lists, but one of the lists is now different. So that doesn't violate immutability of tuples, because the only thing that changed was the list to which the tuple was pointing. Okay, so stop the video and doodle, create your own simple exercise to demonstrate the contents of this slide, then come back. Okay, you're back. I assume you've done your thing. A tuple may be converted to another data structure containing the same data. Lists have many methods that can alter them. The function tuple can convert a list to a tuple. So here I start with my original T1, and it is 1, 2, 3. So then I create L1, which is list of T1. L1 is now a list. And L1 can be modified with the append method. And then I can print L1. And L1 is now 1, 2, 3, 23. And T2 is list of L1. And I can print T2. I could have made this T1 too. I just reused the name, and I would have appeared to have violated the immutability of tuples, but I really wouldn't have. Okay, stop the video and doodle. Create your own simple exercise to demonstrate the contents of this slide. You're back. I assume that you've done your thing. So I want to create a function tsort of t. Its single parameter is a tuple. It's a frutal function which returns the input tuple in sorted order. Test it with ta equal 5, 4, 12, 11. And when you do this thing, take advantage of these facts. The contents of a tuple can be put in a list. A list has a sort method. A list can be converted to a tuple. Stop the video and work the problem. Okay, you're back. I assume you've done your thing. And here we have the function tsort. And this is L. It's not a 1, it's an L. L is a list of the argument. And then I sort L. And then I convert L back to a tuple, and then I return the tuple. So I input TA is 5, 4, 12, 11, print tsort of TA, and you can see that what I got was 4, 5, 11, 12. Okay, that worked just fine. Multiple assignment. This is where you'll encounter tuples most frequently, I think. It's a valuable coding technique in Python. It allows us to extract the values in a tuple and assign them to specific variables. There must be exactly the same number of variables as values in the tuple. So here I have a tuple T1, which hasn't changed at all since the beginning. It's 1, 2, 3. And I assign the contents of the tuple to 3 variables, first, second, and third. And if I print first, I get 1. If I print second, I get 2. And if I print third, I get 3. Stop the video and doodle. Create your own simple exercise to demonstrate the contents of this slide. Or you might try to violate the rule. And here I have 3 things to go with the tuple of length 3. Try and see what happens when you put either 2 things there or 4 things there. See what happens, okay? So go ahead and do that, doodle around, then come back. Okay, you're back. I assume that you've done your thing. Swapping. This is a particular use of multiple assignment. And I've got A is 1, B is 2, and C is 3. And here I've got a tuple consisting of C, A, and B, and I assigned the results of that tuple to the variables A, B, and C. Stop the video and decide what happens before you look, okay? Okay, you're back. I assume you've done your thing. And the answer is 3, 1, 2. Everybody see why that happens? Good. Okay, on to the next thing. This is a more complex version of multiple assignment. I want you to write a Python function to compute both the least common divisor and the greatest common divisor of 2 integers. There are 2 parameters, the 2 integers, which should be positive. The function should return a tuple containing the least common divisor and the greatest common divisor in that order. Stop the video and solve the problem. This one's probably going to take you a few minutes, but please stop the video, do this before you go on and look. Okay? Okay, you're back. It may have been an hour or two, but you're back. So let's go look at my solution. Here is, I called my function find extreme divisors. It has two parameters, n1 and n2. And what we're searching for is the minimum value, which will be the least common divisor, and max value, which will be the greatest common divisor. And I start out by giving those two variables the value none. Then, for I in the range of 2 to the minimum of n1 comma n2, this is the range of possible common divisors of the integers n1 and n2. Okay? So when you're looking at an n1, looking at a value of I, you say, does the remainder on dividing n1 by I, is that equal to 0? If so, then I is a divisor of n1. And this tests to see whether I is a divisor of n2. Well, if both of those two statements are true, then I is a common divisor of both n1 and n2. So now we say if the min value is none, which means we're just starting, or I is less than the current value of min val, then min val is equal to I. If the max value is none, or I is greater than the max value, then the max value is replaced by I. And then what we return is min val and max val. And here's where we call the function. We test it with the numbers 27 and 18. And notice that what happens is a tuple. So this result over here will be a tuple. And we'll assign min value to LCD and max value to GCD. And if we print those out, we get the correct answers, 3 and 9. Okay, tuples may be compared. Equality requires that both tuples have the same values in the same places. Comparison starts on the left and continues until a tiebreaker is found. So TA is 1, 3, 2. TB is 1, 2, 3. Print TA is equal to TB. They're not because the second elements are different. That's false. Print TA is less than TB. Well, if you see the tiebreaker is where you compare 3 and 2, and it is not true that the A thing here is less than the B thing. Okay? Print TA is greater than TB. That's true because these are the same. Here you've got the tiebreaker, and the thing in A is greater than the thing in B. Okay, stop the video and doodle. Create your own simple exercise to demonstrate the contents of this slide. Okay, that's all, folks.